There we go. Hi, Eggles.
Good day.
How are you doing, sir?
I'm well. And you?
I'm very well. Thank you very much. Let's see. I
It
believe
is
you
indeed.
already raised your question in the chat as well. Can you describe the mortar certification process? That's your question, right?
Yes. Yes.
Sure.
As we work with SIBA, the technology for the printer is sound and advances, right? And the software very important, but you develop yourself and you advance and improve that as well. But the mortar, which is dependent uh, to certain areas of the world, right? How do we take what we have? We're not going to ship mortar or material across the ocean. We want to do it nearby. So, but there's some SIBA ingredients that go into that. And so, just curious if you could describe then the process to evaluate what we have locally and how you get it certified.
Sure. So there's two facets to that. One is how to actually obtain a printable material locally. And the other one is how to certify it, and then not just how to certify it in your building codes or locally, but also how does SIBA, how do we certify that something is printable, right? Because you can, of course, use a locally available material and put it in the machine and hope that it prints. It might not be the best way to go about this. So I'll start a little bit about how to get our material at your location. So there's a couple of things. We, of course, sell the SIBA Ready Pack, which is 25 kg or 50-pound cement bags, or a big bag, 1 metric ton, a little bit over actually. And we can send those worldwide. Of course, this material that we use is about 70% sand. And as everyone is very keen on environmentally friendly solutions, shipping sand across the world is not something you would like to do. Also, in the name of cost saving, maybe don't ship sand around the globe. So the other option is that we send the power pack, which is pretty much our magic soup, the cementitious compound with some additives, which is not the 70% aggregate, but 30% of that magic soup, the SIBA power pack. And this material we can also ship worldwide, which can then be mixed locally with the local aggregate. And how do you determine which aggregate you need? Well, we have a sieve curve, right, that dictates the size of the different particles in that aggregate mixture, as well as the percentage-wise content per size. We have a template for this. We can send it to you, and then you look for a local aggregate of the same with a comparable sieve curve. Based on that, we will say, okay, this should work or this doesn't work. And then we find a local aggregate. You send us a sample to our material partner in Germany, Corridor. They will figure out how to tweak the magic soup, the SIBA power pack, to work with that specific aggregate. And then based on that, they can mix a test batch. We test it at our facility to see if it's printable and if it has the properties that we need to print. And based on that, we can ship that specific power pack, the magic soup, to your location, and it can be mixed locally with those local aggregates in a couple of ways. One is you find a local dry batching plant, so a local concrete manufacturer that is willing to mix that. However, for this, you sometimes need quite large quantities before they are willing to do so. We're also now in the state of developing a batch mixer ourselves, meaning that you can mix this local aggregates with the SIBA power pack locally yourself based on your own needs for the amount of material you need. Now, of course, there's the third version. The third option is to pick a locally available 3D printable material. And there's a couple of ways to do this. Of course, Quikrete, who is quite big in the US, but we also have Lafarge, Holcim, Sika, Heidelberg, and a couple of other major cement or concrete manufacturers worldwide that offer a very quick set 3D printable material. We've done tests with a load of those materials, and we know how to handle them through our system. That being said, we like our own material because it sets incredibly quickly and it doesn't crack. meaning our material will set between 3 to 5 minutes, which allows you to print very, very fast, all the way from the bottom of the print all the way to the top without stopping to let it cure, right? Which is important to avoid cracking and wet and to get wet on wet connections. But you are able to use other materials as well. In case you want to develop your own material, that's absolutely fine as well. For example, our partner Hive 3D out of Texas, they, together with a local third party, actually created a geopolymer, which produces around 97% less carbon emissions when it's being made. And they developed that material together with that third party. And they're using that now for their building projects, which is absolutely fine. Normally, what we would ask you to do is send us a sample. We will test this sample of your own material here in the Netherlands. If we say it's good and it's safe to use, meaning it's not damaging to our machinery, then we say, okay, go ahead, use it, and you'll keep your warranty. If you just throw something in there that we don't know about, then I'm afraid we can't offer a warranty anymore, which makes, of course, makes sense because we don't know what you're putting in it. So that's a couple of things about how to get a printable material near you, a couple of different options. And then about certification of that specific material to be used on a building project, that's a complex question, and it's very specific to the region. So what we usually do, pretty much always with our projects, because 3D printing is so new, that even if you use a very well certified material, then the method of using that material, which is 3D printing, might still be hard to get a building code approval on or permits, right? Even if the material is approved, the method might not be approved in the local building code. So what we do, we don't use our 3D printed elements as load carrying elements. We have cavities inside the walls, where after printing you can place a rebar cage, fill it with normal concrete that you can use on any other project as well. And this will be your structural element to your print, meaning that you can comply with local building regulations, even without mentioning 3D concrete printing, because it's not relevant for the structural part of your build. So I hope that answers your question, Eggles. And then if you want to go into real material certification of the 3D printable material, then that's something that's very state dependent, country dependent, even municipality dependent. Or in the States, of course, you have the ASTM concrete code. Stefan Mansour, actually someone that we've been in contact over the last 10 years, is leading that charge within the ASTM community to get 3D printing standardized and up to code. Here in the Netherlands, we have the Euro code, of course, or in Europe. So all of those different code agencies, so to call them, have their own process for this.
Okay. Thank you, Dan. Thank you.
No worries. Thank you, Agus.
Okay.
All right. Next up is Hassan.
All right. Hello, Hassan. Nice to meet you.
Hello, hello. Can you hear me?
Yes, perfectly.
I'm on stage. Great.
Yeah.
How are you then?
I'm very good. Thank you for asking.
My question is about the Gantry robot, the new Gantry robot. Honestly, it's very exciting. It's very exciting to see. We've been witnessing very limited innovation within the area of printing systems in general. So it was nice to see this kind of new advanced printing system. My question is, how do you see it comparing to the normal robotic arm that you use, the mobile one or the stationary one, and with the traditional Gantry system? And if we can be expected to see this system being used on any project anytime soon?
Okay, perfect. Thank you. So yeah, we are very excited about this machine as well. You will be seeing it on a project here in the Netherlands, Q1, very hopefully and very probably, maybe Q2, depending on a couple of code issues, permitting stuff like that. So yes, you will be seeing it. How do I think it compares? Well, that brings me actually to the reason why do we have all these different machines. We believe that all the different printers that you can see in the market today, as well as in our own collection, so to speak, they have their specific place. So, for example, the stationary robotic arm, while it might be the least convenient in most situations, it is quite a bit cheaper than other machines, right? So, for research and development stuff, that might be a perfect printer. The one on the track, it's quite compact setup wise, but it still has a large printing area. So for high production, or if you have very many elements you want to produce at the same time, that's a very useful machine as well. The robotic arm on the crawler, of course, is very flexible. You can use it on site, on the job site, semi on site, as well as in a precast manner, but you can still drive it around your precast warehouse. So that's a very flexible machine, and a good reason that we sell that one the most and use it ourselves the most as well. And then there's always the discussion robotic system Gantry, which is a big one. And up until 2020, I believe, or 19, we said the robotic system is just better. The Gantry doesn't make sense. It takes too long to set up. It's too bulky to transport. If you want to use it on the job site, you're spending a week or 2 weeks setting it up. They need another couple of days to calibrate it. Then you can print 40 centimeters in one day because it's too slow. Then the next day, your 40 centimeters are dry, and you have to put wet material on the dry base that you printed the day before. If it's windy, if it's rainy, a whole lot of mess, just not efficient because you're not printing as much as you would like to do. So your overall equipment effectiveness is very low, which makes it very hard to make your business case closing, because a printer is like an airplane. If it's not flying, it's losing you money. It's costing you money, actually. And the same goes for a printer. If it's not printing, then it's costing you money. So we decided against gantries for a long time. But then we decided, okay, a gantry has its place in the market as well, just not on the job site, right? Because on the job site, if you only have this much space and you want to make your building this big, you can't do it because the gantry needs this amount of space to actually put it up. So we thought, how can we use a gantry and why is it still popular? Well, for a couple of obvious reasons. It has a large printing area, right? But we decided to make a gantry to be used in an off-site manner, so you can do precast modular construction with it. Then we decided, well, if we do want to do that, we need a gantry that's fast, and preferably as fast as our robotic system, which is 0.5 meter, 500 millimeters per second, which is about 1.5 foot per second for all our US viewers, roughly around there, I believe. So, but then you come to the issue, if you want to make a gantry that goes 0.5 meter a second, and you want to make a 90-degree turn, then you have a beam which is around 200, 300, 400 kilograms that you have to put to a halt instantly to start moving in a different direction, which makes it a very complex machine to make stable. And then we came out with, how can we make the gantry, the heavy parts of the gantry, move as smoothly as possible, so no harsh acceleration or deceleration, but still have very fine print nozzle control. And then we came up, we'll just put a robot on it, right? So our gantry, the beams, the XYZ of the gantry will move in a very curvy way, and then the robotic arm will just make the corner, right? And this allows us with that gantry robot to actually have a very high accuracy, a very high printing speed, and still be able to do sharp corners and high details. So that's kind of how we got to the GR. All that being said, even after all those developments, we still don't feel that a gantry has any right to be on the job site, and we won't be using it for that, for the reasons I gave earlier. But we will be using it for PPVC, which you can find on our website images of this, but it's prefabricated, pre-finished volumetric construction, meaning that we will build container-like units with the floor and the walls being printed in one go. And these modules will be finished with utilities, windows, doors, kitchen, bathroom, all of this in a facility, will be shipped to the job site and assembled like Legos. And we believe that this is the future of construction. So I hope it's a bit of a wide answer, but I hope it answers what you were asking.
Yep. Thank you so much. Answers everything, and I'll be looking forward to the project.
Perfect. All right. Thank you very much. Let's see.
Can answer the question from Francis in the bottom.
Yeah, sure. How much HVAC and insulation are required for a 3D printed home compared to a traditionally built home? Let's see. I don't think I understand your question properly, but I will try to answer it to what makes the most sense to me. I believe your HVAC and insulation requirements are not based on your construction method, but on your local building code, right? So you have a specific delta T, your difference in temperature outside and inside, and you want to minimize that or insulate the inside as much as possible. For example, let's say, where was this very low? We were in Florida, where the weather is in general quite warm, and the insulation values there, or the insulation requirements, are not high at all. In the Netherlands, for example, we have quite some chilly winters. They're not like super cold, but they do become a bit chilly. And we also have a higher environmental standard on how much our houses have to be insulated. And then we adjust the amount of insulation and HVAC based on those local requirements. So I don't think the construction method changes that between traditional or 3D printed. It's just about the total R value of the building or of the wall element that you print. To give you an idea, for example, in Florida, we printed a 2-layer system, and in between, so that means that you have an inside wall and an outside wall when you're printing. And in between those 2 layers, we would have added some form of aircrete, I believe was the name, which is a very low density concrete mix that has a certain amount of insulation as well as structural integrity. And that was enough. We can't do that in the Netherlands. In the Netherlands, we need a 3-layer system where the inside cavity can be used for HVAC, electrical, plumbing, stuff like that. All of that you can put in that cavity in the wall. And they have a 3rd layer with anchors connected to that, to the inside 2 layers to avoid cold bridging. So there's no concrete connection between the outside layer and the middle layer. And in between that layer, there's insulative material. And you can vary the thickness of that cavity to add more or less insulation. So I hope, Francis, that answered your questions. If not, please clarify, and I will try to answer it better. I believe that's quite an answer on insulation. I implementing a private building in Saudi Arabia. We have been in Saudi Arabia for a project. I believe this was for the Ministry of Housing, a demo project. So that's not a private building yet. We are working again with some Saudi contacts to maybe do some new work in the region. For now, we are not currently working on a house in Saudi Arabia. We could, we can, we have the capabilities, and we've done it before for the Ministry of Housing. I believe it might be for a different agency, but it's been quite a while, 2018, I believe, top of my head. But currently, we're not doing any projects in Saudi Arabia.
Then we have a question from Alex. I'm going to bring him on stage now.
Hi, Alex.
Hi.
Good to see you.
Can you hear me?
Yeah, we can hear you.
So my question is, we're looking into buying the RC or the R robot, and we want to know what its limitations are, or really what are the limitations on 3D printing for size-wise and then storage-wise. So how many floors can we build with it? What's its weight capacity? Because what we want to do is build 3D apartments. And so we just want to know, what is the limitation there? How much can your proprietary materials build, or, what's their load essentially?
Yeah. So if you're talking about the printer itself, the size of the building, width-wise, is not really a limitation, right? Because it's all modularly built, so you have just more elements that you need to use. Then if you go up in height, there's a couple of ways to do this. In general, like I said, with the material certification, we don't use our material to be structurally load-bearing. We use normal beams and column structures, which can be casted directly into the cavity of the wall. So you don't need formwork for your reinforced concrete beams and columns. And based on the thickness of those columns, you can go up as far as you want, relatively speaking, right? You're not going to do a 40-floor building straight up, but you can go up quite a bit. What we do tend to use, advise you to use to go multi-story, especially multi-family apartment complexes, stuff like this, is the gantry with a robot, and then using the PPVC, prefabricated, pre-finished volumetric construction, so modular building, because all the structural elements are built in those modules. So the only thing you have to do is stack them on top of each other and connect them with dry connections, right? This technology, or this building methodology, we actually developed for a challenge. I believe it was in Canada. It was a project there, design project, structural engineering project challenge, where we designed that building, which, don't pin me down, but I believe it was ground plus 8 or ground plus 12. And then we did another challenge in India, which was either ground plus 8 or ground plus 12. So one of the two. So that technology has actually been developed to go 10 and above, right? If you go with just the printed wall elements using the robotic system, we don't suggest you go higher than 2 floors. We just haven't done any designing for that. We don't think it's cheaper to use 3D printing with a robotic arm for more than 2 stories because of your hoisting and the height of the crane you would need and stuff like this, and complexity as well. So if you use the robotic system, I would say 2 stories. If you want to go higher than that, definitely check out the Gantry with a robot. In general, if you do have a conceptual design of what you would like to build, please do feel free to reach out via the contact form. Just select, I want to buy a printer, then your incoming request comes to me. You can share your conceptual design and we can take a look more in detail what might be the best solution for you and how can we make a business case around this design.
Okay.
Also, a bit of a different question. In that contact form, please give me some information on the camera you're using and the lighting, because for some reason your image looks more professional than ours.
I've been told that, yeah. And it's not even that expensive of a camera. I think it's like $30 US. So
yeah, we need that info. Yeah. Nice setup you have there. Does that answer your question, Alex?
Yes, it does.
Wonderful. Thank you for the question, man.
Thank you.
All right, let's see. If you ever looked at incorporating fiber content and which fiber? Yes, we have. So we've done a couple of different fibers. I believe we've done some glass fiber, we've done some hemp fiber, and we've done steel fibers. And the reason that you usually use those is to increase the tensile strength, right? So that's one. The bigger reason that it gets used in 3D printing is to avoid cracking, right? As everyone knows, concrete, when it's curing, it expands and it shrinks. There we go, that's fixed. It expands and it shrinks, right? While it's curing, while it's dehydrating. And the reason that we don't like to do a wet layer on a dry layer is because the dry layer will be expanding and shrinking at a different rate than the wet layer, which causes internal tension, which causes cracking with most materials. So what a lot of people do, they add fiber so that the tensile strength of the material is higher, so the probability of the material cracking is a lot lower. We don't use fibers ourselves. Why? Because our material doesn't shrink or expand while it's curing. That's one. Also, we tend to print elements no longer in length without indentation, longer than 3 meters or 9 feet. So the expansion amount, even if there is a little bit due to temperature changes or whatever, is not enough to crack the material. So for us, there's no need to add fibers. Also, fibers tend to have increase the probability of your nozzle clogging, especially with steel fibers or very stiff fibers, whatever those may be. The chance of clogging your nozzle or your mixing iron is a bit higher, which is a risk that for us is not worth it. And then when we tested it, the tensile strength increased by so little that it wasn't worth it to us. Also, the compressive strength decreased a little bit. And all those things are possible. So adding fibers is definitely possible, but the pros didn't weigh up to the cons for our system specifically. So Nigel, we can do it. For us, however, there's no reason or need to do it. And then Nigel, another one, you mentioned low embodied geopolymer mortar solution in Texas. Do you see this as a general direction of travel to go cement-free lows? Yes. So we think geopolymer has immense use cases. There's just one big problem with geopolymers in general. The reason that they're so low in carbon emissions on paper is because they make use of waste streams, right? So iron production, aluminium production, I believe some use red slag. So for the people that don't know this is an aluminium, I believe it's a waste stream of aluminium manufacturing process, refining, aluminium refining, or aluminum for for the other side of the pond. And those things are usually localized. So in Texas, our partner Hive, together with their partner that makes this material, they have one of these waste streams in their backyard. So there's a very low amount of transportation cost of getting this waste stream to the batching plant. And every material in this 3D geopolymer that they're using is quite local. So very low transportation, and it's a waste stream. And both of those add up to a very low emission. However, if we would order this wonderfully working material from Texas and ship it all the way to the Netherlands, where we are located, then it's not going to be carbon free anymore, right? Because you have to ship it across an ocean. And this is complex. So you need, for every place where you want to produce such a geopolymer, you need to find local waste streams and local ingredients that can be made into a printable geopolymer without having to transport them over long distances. So while we do definitely believe in the potential of geopolymers, you need to find local waste streams to make it work, which makes it quite complex to roll it out worldwide. It's step by step, location by location. Let's see. Fariza, I hope I'm pronouncing that correctly. What's the highest compressive value you have achieved? What's your strategy to prevent interface problems between layers? I believe the highest compressive strength we've ever measured is 48 megapascals, which is Newton per square millimeter. And I believe that translates to 6.5 or 7,000 pounds per square inch or psi. Quentin will look it up, but I'll put it here. I believe the highest we ever had is mph, and that would be mph to psi. Give us 1 second, we're on it. Yeah, so that is, according to the internet, it would be 6961. Yeah, so let's say roughly roughly 7,000 psi. In general, however, we're a bit lower because to get this compressive strength, you need a bit higher of a cement content or power pack content, which we don't need. Usually, we don't need this strong of a material because, like I said, we don't use the walls as a structural load-carrying element usually. We have done this in the Netherlands, though, where we use the walls as a structural element. We could do that because there's a certain part in our building code that says if you test a certain element, whether it's wood, carbon fiber, 3D printed concrete, whatever you want to use, you can make this structurally load bearing according to code, but you have to build it, test it to breakage, and then test how strong it is, and then you have to put a factor on it, and then you can use it in an actual build. So we use that for a Dutch construction project where we actually use the printed elements as load-bearing elements. But in general, this is the material strength. I believe in general we're right around 35 to 40 megapascals, which is between 6,000 and 6,500 psi. And then for preventing interface problems between layers, well, because we print so quickly, we always print wet to wet. So when we put a new layer on the old layer is still so wet that it pretty much cures as one element. So it's not that this is almost dry and then we put some wet on it and then you have different curing rates, or not rates, but they're at a different phase of the curing process. We tend to avoid this by having the layer time, so the time between two layers on top of each other, so short that they're in the same phase of curing. So we don't have bad interface problems between layers. I hope that answers the question. Let's see if I missed anything for now. But while we're waiting on some other questions, if people have them, which would be great, of course. While we're waiting on those to come in, we have a question for you actually. We have a goal for 2023. Well, we had multiple goals, most of which we succeeded beyond our expectations even. But there's one that we still haven't gotten to completely. So we have a LinkedIn page, as do all companies, right? And what we're trying to do is get to 8,000 followers before the end of the year, which would make Quinten from marketing very, very happy with himself. So if you haven't done so already, please consider following our LinkedIn page. I believe there is a link or a pop-up on your screen below. You can also, of course, find us, Ciba Construction, on LinkedIn and just follow the page. We would very much appreciate it if you can do that. It would be great to get to 8,000 before the end of the year. I believe we need less than 100, so let's make it happen. Next question. Hi, I'm Kartik from India, studying final year structural engineering. My college project is replacement of RAC in 3D printing concrete. I've done some preliminary tests only. The replacement decreases the workability of the mix. What do you think about this case? Suggest optimum. All right, now we're getting into the nitty-gritty material detail stuff. I'll be quite honest with you directly. I don't know. I don't know a direct answer to this. I'm not the material expert. I can see maybe give us a little bit more details, and I'll try to see if Quinten can find some stuff about it that helps me answer your question, and then I'll get back to it if that's okay with you. Can you see if we can find it? Cool. Cheers, Alex. Thanks for the link. Nassim, why can't I access the courses and models? I believe you are referring to our library. and I don't know if you have an account to our library or at least a paid subscription. If you don't, then that would explain why you can't access them all. If you do have a paid subscription already, then I would suggest referring you to the help desk of the library. You can also send an email to me directly and I'll figure out why you can't access it. But the library is, of course, our educational platform with models and courses, data sheets, and all of this. But this is behind a paywall. It's, of course, included in the purchase of a printer, or if you purchase a course, then you get some access as well. But not all information is freely available because, of course, a lot of the work that we've done over the last 10 years is reflected by that library. So we haven't published everything for free. I believe there is a free course to begin with that you can join regardless. So you just have to make an account, go to the course, and then you can enter the free course as a sneak peek, so to speak. If that doesn't work for you, Nassim, then please do send an email to, for example, sales@siba, which is me, or via the contact form on the website to see if we can figure that out for you. Nereo, hi, I'm Nereo from Argentina. What are your thoughts in hempcrete and the use in 3D-CP homes? Hempcrete has its pros and cons. I think there's definitely some potential there, but you would need some changes for to the printing system itself. I think personally, and this kind of reflects the thing that we think at SIBA as well, is that if you have a material that's as close as possible to regular construction material, but then use it in a smarter way, then that allows you to optimize your building process as much as possible without changing a lot of other stuff. Right? I think it has potential. And our material experts have taken a look at it. For now, it's not interesting for us specifically because it's changing too much at the same time, which makes it hard to actually get a permit to start building and stuff. So for this reason, we stick to what we know so we can actually help our partners build without making too many changes. But there is some potential there, definitely. I hope the connection is still okay. I got a message from our webinar program that we have an unstable connection. Please let us know if the connection is breaking up or if it's bad. If not, I'll just keep going. All's good. Thanks, Alex. Cheers. Shipping costs to the US for the robot depends on the location in the US. So if we want to go to the Miami harbor, for example, or the East Coast in general, then that's quite a lot cheaper than the center of America or the West Coast. Normally what we do, we have a provisional sum of, I believe it's around 10,000 to the Miami harbor, or let's say 10. That's including the seaworthy packaging. And then from there, of course, it has to go on a truck or it goes to the canal to the other side or whatever. In general, we do 10,000 for a container to Miami from the harbor of Rotterdam. And then to the other side, the west of America, west coast of America, or the middle of America, we usually do provisional sum of 15,000. If it's less, then of course that gets reimbursed. If it's more, then it's invoiced after. But let's say rough numbers between 10 and 15 to ship it to the US. What is the market for 3D printing in terms of application and countries? Who is your biggest client today? Boom. That's a good one. So application-wise, the easiest thing to say is everything that's currently being made out of concrete there is someone out there figuring out a way to do it with 3D printing. So we have street furniture, landscaping, gardening, public facilities, bus stops, stuff like that. Also, foundation blocks for electrical posts, certain utility frames for solar panels on top of parking areas. There's some people doing that. Then we have a partner in the US who actually does dropping anchors for floating windmills. They're working on that, which are usually made out of concrete, but the shape is quite complicated. So they decided to print that. Then, of course, there is construction, housing, commercial units, artificial reefs, a very big one worldwide. Then we have seawalls, like our partner Kind Design is doing in Miami. So they're printing seawalls to protect the Miami coastal line. What else do we have? Traffic islands. So our partner in New Zealand, they actually printed a traffic island for on the roads, right, for traffic to drive around. Water collection basin for rainwater. So there's a lot of slopes in New Zealand. If it rains very hard, then you get a lot of rain rolling down the hills. And what they built is actually a big basin in the shape of the mountain to collect this rainwater and to release it slowly again to stop flooding. Massive amount of applications. Our biggest region right now is the US, where the most interest is coming from, because the US is really pushing this and there's a lot of companies doing it there. So the US market is massive for us. Middle East is also quite big in regards to amount of projects being published there. It's a bit of a different market to get into, but we've done some projects there. I believe our biggest clients right now are Aizawa out of Japan. They currently have 3 of our machines. Then we have Timothy from Hive 3D in Texas, who has one of our machines, has currently ordered 4 more. 3 of those are currently being produced to be shipped to him early next year. And then we have Anya from Kind Designs doing the seawalls in Miami. She has 1 printer, currently has ordered 2 more. So what we're seeing now is that clients that we've had for a little bit are now actually scaling up. So they're growing their business based on the technology. They are actually they have to buy more of these machines because they're filled to full capacity. So they're printing every day and they need more to start printing more at the same time, which for us is a really great thing to see. That means that customers are not only trusting us for buying the technology once, but they're actually growing their business, making money, and able to buy more of the machines to grow their business, which of course is always very good to see with newer technology. So it's not just a gimmick, they're actually using it on a bigger scale. I hope that answers your question, Fariza. We're looking to invite our partner Texas A&M for February's. Oh, that's you. So that was us. Yeah. So about hempcrete, they might be able to tell us a little bit more about that. Let's see if there's anything else. Oh yeah, for the question from India, I don't think I'm able to answer that question properly. I can maybe look something up real quick, but if you want to work on that problem specifically, then I would recommend you reach out to us via the contact form, and then you can say I want Siebert to print my project, because that goes to the commercial lead of our building and society team, which are also our material experts. Architects and structural engineers are in that team as well, so they will be far better equipped to answer the question than I am, Kartik. Volume printable per use and by day. So our mix and pump system that we currently use has about volume flow of material of about, I believe, 1.6, or a mass flow of 1.6 tons of dry material per hour. So that would be, including the water as well, would be roughly 1.8 to 2 tons of material being printed every hour. Of course, if you do very small elements, then you have to start it up. So you have to get some material to the machine, make sure the consistency is correct. You will lose some material, about a bucket or two, if you're experienced. Then you can start printing, and then to stop it and clean it, you also lose a little bit of material, which is about 1 bucket, big bucket. If you print more in one print, so either 2 walls, 1 big wall, a couple of different smaller elements, then you only have to do this startup and finish procedure once, which really decreases the amount of material that you waste. Already with this technology, you waste very, very little because you place it exactly where you need to place it. But the bigger or longer prints you do, the better. In general, we don't like to print for more than 3 hours. We have done a print of, I believe, 5 or 6 hours at one point, but the rotor stator pump in the system, it likes to be flushed every now and then, so no material can build up. So in general, we don't print for longer than 3-4 hours in one go. After those 3-4 hours, you take apart the system and clean it real quick for all the material that might have built up. You flush it, and then you restart it, and this entire process can be done in 15 to 20 minutes. It's super simple because it's quite a compact system. Also for the gantry, the same happens for the basic gantry, because you can just flush the hose as well, which is very comparable to our robotic system. So I hope that answers the question. Let's see if there's anything else.
I had 2 more questions in private chat. One of them is about printing leasing rates.
Printing leasing rates, that's also super region dependent. We do our leasing via third parties, because of course, if we are in the Netherlands and we want to lease something to Peru and the person doesn't pay, then it's very hard for us to get that machine back. So we have third parties arranging our leasing terms, and what they normally ask for is some company information, financial background and history, and maybe a credit check. Based on that, they will offer a certain leasing rate that can go everywhere. So there's not one number I can give you. We don't lease it directly ourselves. Development of 3D-CP market in Argentina. I think in general, South America is a massively growing market, especially now. Of course, Argentina has a complete regime change, so a lot of stuff will change as well. So I think it's a very open market right now to develop new technologies. I think it will be massively interesting, but we're interested in developing this everywhere, right? If we can have a good design that complies with local regulations, we can make a business case, and we can make sure that you as our partner will become successful with local material developments, with support of design and engineering, stuff like that. If we can support you to become successful, then of course we're very excited to help you do so and grow your business. But South America, Argentina specifically, I think is a very good market. So if you're interested, Nereo, to figure out if there's a possibility there, feel free to reach out to us via the contact form. Maybe share some more information on your project or on your business case, what you're planning to do, and maybe we can see how we can work together to make a business case and to actually supply you with the technology needed to start 3D printing in Argentina. What's the current cost of each system you offer? RC, Gantry, etc. So there is a price sheet. If you actually, if you go to our contact form and you fill in your information and you select the option, I want to buy a printer, you will actually receive an automatic response email. In this email, you will find the data sheet for all our printers, a price list, as well as the lead times, the updated lead times, You will also find some links to videos and to these webinars. So there's quite a lot of information in there. Keep in mind that all the prices we give in that automatic response are budget quotes. For example, our Gantry, or let's say the robotic system on a crawler, the cheapest one, the least expensive one, the most basic one that I've ever sold is around 220 or 215,000 euros, and the most expensive one I believe ever offered was 375,000, because there's quite a big amount of different options you can put on this machine that are needed for your specific use case. So the budget quote you will receive in this automatic response. Do check your spam, because SIBA and cyber are kind of alike. So for some reason, most email providers don't like if you receive something from us, because it looks like cyber too much, which is annoying. We know, but it is what it is. So if you reach out, do go into your spam box to see if you have your response. And then you will find a budget quote if you want to get into the more specifics, like what printer do I need exactly for this design and how much would that cost, including transport and stuff like that. Feel free to reach out to me to respond to that automatic response mail. And then I will reach out to you to plan a one-on-one meeting to discuss your specific case. And then I can give you a quote based on those specifics. Is there a code or a standard for designing homes using 3D printing in concrete? Well, not specifically, and not, well, in some places there might be, but in general, we don't see that yet, because those coding or standardization processes take a couple of years, and they're not worth the hassle, because in a couple of years, the way that we do 3D printing might be completely different, right? Which you can't do. It would hold development, because everything has to comply with the code. So what we at SIBA do, we actually use 3D printing in such a way that without mentioning 3D printing, pretty much, it still complies with the code. Right, so we work around that. It's not a loophole really. It's just code compliant building using a different technology. And there's different ways to do this. We've done this in New Zealand. We've done this in Morocco. We've done this in the Middle East, in Dubai, in Saudi Arabia, in Japan, in the US. So there's all of those different places in Paraguay actually. So all of those places have different building codes, but we can change our design and the way that we use our technology to comply with those codes. This is something we've done worldwide, so we can also do that, Nassim, for you if you would like to discover that further. Sure, Francis. Give me 1 second. I'll check. Researching in development for social housing and other stuff, and would love to meet. Yeah, perfect. Reach out to us via the contact form. Select I want to buy a printer. Also, this will answer your question a little bit, Francis. Just reach out to us and select I want to buy a printer. That brings you directly to me. I do not only do business sales or business sales for printers, but also larger business development things such as partnerships or joint ventures. So you can still select I want to buy a printer, and you'll get to me, and then we'll in the first meeting we'll discuss the specifics. In general, the way that we start partnerships is pretty much always with purchase of a printer. So if you want to become a partner of ours, you have to have a printer, because you need to know how to use it. You have to have a team of people that know how to use it. You have to know how to build with it, how to do construction with it, because it's important for us that our partners are capable of explaining our technology. After that, we can come up with a partnership where you could be, for example, a first mover in your region, meaning that if someone else close to you wants to buy such a machine, then you can reach out to them, or we will give that lead to you, and you can decide, oh, I would like to pick up this lead. I would like to sell a machine to them, and then you can get a commission on the sale, but you can also get a commission on training them, and also get a commission, for example, on service and support. So they will be under your tree, so to speak. So you will be first mover, they will be second mover, and if they have a question, they can come to you, and otherwise they can come to us, of course. For this, we have a partnership agreement template. So, Francis, if you would like, reach out to us via the contact form, and I can share that partnership agreement template with you. The start of such a partnership, however, is always the purchase of a printer. So we're not looking for resellers that just want to do a little bit of a sales network and then call us like, hey, I have a lead, give me this amount of money if I sell for you. Not interested in it. We can do that ourselves. We have a sales team ourselves. We like to have valuable partners that actually use our technology to build, to do seawalls. That's for us very valuable. And the great thing about that partnership and the community that we're building is also that they communicate. So, for example, our partner Kind Designs in Miami, they had some issues or with productivity. They wanted to upscale their productivity, and our partner in New Zealand had a solution for that. So Wafe from Corox, he's been there about a month ago, and he's currently now again in Miami to help out that other partner. So we have this community of partners that help each other grow as well, and that and we learn a lot from those guys as well, which helps us to expand again. So we have a nice close-knit community of partners, and if you're interested in how that works in more detail, please do feel free to reach out to me, Francis, or anyone else that's interested. And I can share that partnership agreement and we can have a chat about it in more detail. Perfect. All right. I think that is it for now. I don't see any more questions, and I believe we're pretty much at the end of the planned time. So I think that's it for me. Thank you all very much for being here. Also, thank you all for following us on LinkedIn. And don't tell me you didn't do it yet, because I know you did. Yeah, we had 17 attendees, so we should have at least 17 extra followers right now. Most of you probably followed us already, so that's not going to work. But perfect. Thank you, Alice. Thank you, Eggles. Thank you, Nigel. Thank you, everyone, for the interesting questions. Like I said, if you want to get in touch, fill out the contact form on our website, and then we can have a chat. Keep in mind, it is a very busy period and the year is almost up, so I might not be able to get back to you before the holidays. But in the new year, I'm very excited to speak to all of you that are interested in having a chat and to see how we can grow our CIBE community. For now, from everyone here at CIBE, I will wish you a very, very Merry Christmas and a Happy New Year. And I hope to speak or see all of you in the new year again. Thank you very much. Bye-bye.